Hi everyone. Here again we have another part B. Actually, I did part A already, and part B says the c to the times square root of x, where x is between 0 and 4. So first thing we have to find constant c. Constant c, to find c, we know that it's c square root of x. But we could write that as c times x power half. Then you would take because it's a PDF, so we would take the integral, which is integral from 0 to 4, c x power of half dx. And that now would equal to, when you would have cx 3 halves, and divided by 3 halves would be that would be 2/3. If you remember your integrals, how to do integrals, then you would see how I get that. I'll just say it's 1 divided by 3 halves, which is 2/3. And from 0 to 4, and that will give you 16 over 3c. And that equals to 1. Because the probability of everything equals to 1, so c would equal to 3 over 16. So your PDF would be 3/16 square root of x. Now your CDF now. Now let's do the CDF part. The CDF is just, instead of writing x, you write c. So you would have, instead of having a 0 to 4, so you would have instead 0 to x, because then where x is going to be. So you can't just put a number right on top. You know where it starts because you have to start from 0. But you might not finish at 4, you might finish at less than 4, so you just put x. Then because you put x here, I would put t. So I get t 1/2 dt. And that now would equal to, oh, but we know what c is already. My mistake here. We know that c is equal to 3/16. So 3 over 16. So now you add 1 to t half, which is 3 halves again, and then you divide by by 3 halves. That will be 2/3. So that will be 1/8. 1/8, and that will be from 0 to x, which would give you 1/8 x 3 halves. Now, the CDF now would be, remember, the CDF always has 3 parts into it. It has the part where it's 0, where x is less than 0. The other part is 1 over 8 x to the power of 3 halves. That is when 0 is less than or equal to x less than 4, and equals to 1 whenever 4 is less than or equal to x. So that's basically what it is. Now, to find that, that's the CDF. Now we need to find mu and sigma squared. Mu is the integral of x times f of x. So you have from 0 to 4, x times f of x is, we know that f of x is 3 over 16 times x to the power of 1/2. But x to the power half times x is equal to x to the power of 3 halves. And that would be dx. And on your calculation, you would get basically, I think it's 3 out of 40. So when you add 1 to that, that will be x to the power of 5 halves. And you divide by 2/5. So you would get 3 out of 40. Yes. And that's from 0 to 4. And you guys can do that by yourself. Let me just give it that little part right here, not to confuse it. And now the variance, which is sigma squared, is when you take the f of x times x squared, so you have 3 over 16 x squared times x to the power of 2 times x to the power of half is equal to 5 halves. So 5 halves dx, and that would equal to 3 to, now when you add 1, that will be x to the power of 7 halves, and you would divide by 7 halves, which is 2 7. So 2, that will be 6 over, but yeah, that's going to be a long one. So basically it will be 2 times 2 is 6, and 7 times 16 would be whatever it is. So that's 112. That's 112. And that will be from 0 to 4. So that will be your sigma and your sigma squared and your mu. But you guys can calculate that by yourself. So let's go ahead and graph the PDF and the CDF. Basically, a TI-89 titanium and a TI-89, they all work the same, so it doesn't matter how you do it. So let me show you how to do it. You will go to custom, or the green button here, and click on F1 to put on the 3 over 16. So I would have 3 over 16. Now, it would be easier to actually, sometimes, guys, I want to tell you right now, it is easier to just put it as in decimal form. So, instead of doing that, you just type 0.1875 times x to the power times x to the power of 1/2, which is 0.5, and enter. Then I will go to graph. I'll graph that, and that's what it gives. Just gonna go to the green button and press F2, and I'm going to, I'm going to change that to x max to be 3 or 5, and I'll go here and click on graph again and see how it is. Okay, so now I'll go to F5 and click on number 7 for integral, because it's from 0, right? So 0 as the lower limit and 4 as the upper limit, and click enter, and here is the graph, and that's how it would be actually. That's your graph right here. So now that we have that, we would have the, basically anything before 0 will be nothing, just a straight horizontal line from the x-axis, and once you pass that, wherever the graph here shows you, it will be a straight line on the top, because at 1 it will be just 1 all the way. So that's what it is. Now let's graph the CDF now. The CDF will be, I'll just erase that part right here. The CDF will be the same thing. I'm going to graph the 1/8 basically. So 1/8 will be 0.125 x to the power of 3 halves, so times x to the power of 1.5, and click OK. Then I would click on graph just to see how it looks like. So this is actually going up. So let's just go into, now click number F5 and click number 7 for integral. Lower limit is 0, enter, and upper limit is 4, enter, and let's see how the graph looks, and here we go. So basically, guys, I'm going to make it smaller I'm going to start from -2 here, and graph it, so you guys can see what I was saying earlier about the how you would show it on your paper. 0, enter, 4, enter. What I was saying is this: when you show your graph from your paper, from here to here, that will be the 0 line. That will be like no line right here, just no line. I mean, you would just highlight that part on the x-axis from 0 all the way to -infinity, and from 0 to 4 he would highlight this part right here, and after we reach that number 1 here, which is this one here, then it would do from here all the way to infinity will be a straight line, because if it's equal to 4, then it will be 1. So from 4 all the way up, then it will be just a straight line, which is the 1. So this is what it is, guys. That's how I was hoping you guys would understand. And I actually enjoy doing this, and I hope you guys understand. And basically, that's about it for right now. Now, if you have any comments, please comment. Ask me if you need some explanation, and I'll be glad to make another video or respond, typing it on YouTube. But other than that, guys, thank you for watching, and have a good day.